Good afternoon. My name is Michael Epprecht. I'm a technology specialist in the global black belt team, in the cloud and enterprise team. I cover mostly the Europe, Middle East, Africa region. I'm a technology specialist. I'm not a program manager. I don't work for the product group. I work with real customers. I'm there with the customers doing architecture design sessions, doing technical presentations, and guiding them through the project. I'm not a consultant either, but I'm involved during the whole project, especially on the larger projects. So, Explore IoT Scenarios from the field and their reference architectures. These are real architectures implemented at real customers. I will go through the pros and cons of some of these architectures. I will also go through our reference architecture to give you an idea what is actually being done out there. Now, IoT is not anything new. When I used to work at Siemens 15 years ago, I used to do machine to machine. The difference between machine to machine and IoT is we've got the cloud. We've got a huge amount of compute capacity. And that's actually what we're seeing. The old style machine to machine wants to tap into the cloud. So there's a lot of brownfields implementation where we have to make compromises to make the project work with what they've got out there. And I will go through a few of those. Good, but Microsoft has published an Azure IoT reference architecture. Who has seen this before? It's about 3 or 4 people in a room. Now, this is that typical reference architecture where they're saying, this is roughly the way the data would flow, the way the things would be connected, and what would happen to the data. So let's quickly look from left to right. This is base. You might have a device who can connect directly to a cloud gateway. In the case of Azure, it will be the Azure IoT Hub. The older version of it, or its little brother is the better term, would be Event Hub, and its smaller brother is Service Bus. So you might have devices who can connect directly to IoT Hub. You might also have devices who need to route via a gateway. You might even have devices who do not have IP capabilities like Bluetooth, or they might have some other technology stack like Zigbee. So those need to be translated into IP before they can go into the internet. A good example of a gateway is a car. Your central computer in your car is the gateway. You don't connect every sensor of the car to the cloud and then let each one talk. It all gets aggregated on the gateway, and from there it moves on. And I'll touch on a few of the gateway things out there. Now, the cloud gateway, that is IoT Hub. That's a massive ingest platform which really talks with which the devices connect to, communicate with, bidirectional communication, etc., etc. Then we get into the standard Lambda architecture, where you have something that takes the data out of IoT Hub and throws it into storage, as it is probably in the original format. Why? You never know what the data scientists can do with this data in future. And with cloud storage being cheap, a few cents per gigabyte, for the price of a Starbucks coffee, you can store quite a bit of data per month. So you tend to put everything in its original format, write it into the storage, and leave it. You might from there then start doing some processing against it, but that is your original version of the truth. Then the other hot path, as they call it, would be to do streaming and analytics over this data, maybe using something like Azure Stream Analysis, or something like Storm from the open source world, where you're looking at the data real time as it's flying past. And then you might be doing some further analytics, and you might be calling out to machine learning, and you might be doing some more work, and naturally then there's some integration to some back-end systems, because that's what users want. They want some UI, they want some integration. And then naturally, there's always a requirement for some form of identity registry. And that's the device store plus IoT Hub, because each device needs its own authentication. If you were at the security session yesterday, that was made very, very, very clear that you should have each device with its own tokens, its own keys, to make sure that if one device gets compromised, not all devices are compromised. It's very interesting if you've got one key on 1 million devices and one of them gets compromised. You're in effect lost 999,999. And of course, you want to keep metadata. Now that metadata might be your ERP system, it might be some database, it might be some NoSQL database that stores that information. Naturally, there might be a lot more processing to be done on some form of app backend, and then there's naturally some user interfaces. Now, IoT, as you see, is an integration project. I call it the world's largest integration project. Because what are we taking? Taking devices, integrating data, enriching the data, adding more data to it from existing data, and then feeding it to something or a human, or doing a feedback loop and acting on that device. Now, the business does not care about everything on the left here. For them, it's the necessary evil that needs to be done, that they get a report or they do integration. The end game is, for business, this. They don't care if we're using the coolest protocol. As long as it works and as long as it's secure is generally what I hear. I don't want to hear about your technology. I don't want to care about TCP/IP stacks. I just want my data, but please make sure it's very, very, very secure, because I don't want to get hacked. And as was touched on yesterday on the security session, security in depth. There are multiple layers here of security. It's like an onion. If any one of those layers is weak, you've got a problem. If your device is easily compromisable because it's the fire sensor in this room and somebody can walk up to it and pull the software and the firmware and also the keys off it, well, you can't really trust that data on the back end. If your field gateway isn't trustworthy, well, you can't really trust the data that's coming through it, because you don't know if it's been tampered with or who's been listening to it. The cloud, that's our job to secure. I mean, IoT Hub, and after that, that's our job. We are continuously doing that. That is us as Microsoft's job. So this reference architecture, as you see, has got no product names in it. It's quite generic. You could stick even any open source names in there. You could stick even some web services or some other technologies in there. But we'll touch on why not a bit later. Now, you've probably heard about Azure IoT Suite, and you're thinking, yeah, okay, what product is that? Well, it's not a suite. It's a solution to start you off on an IoT project. You can either start blank slate and say, I'll stick everything together, Lego blocks, take all the various components from Azure, or you take this and you start sticking it together. Now I'm going to quickly touch on that architecture. This is the remote monitoring architecture. This is the remote monitoring solution. It's a screenshot of it. When you deploy it on AzureIoTSuite.com in some Azure subscription, it spins up some simulators and it starts producing data. And then you can look at this data. You can then connect the device, etc. So what does that architecture look like? Because now here comes some real-world architecture that's really running out there that you can go and touch. There's these C# simulators. They talk to Azure IoT Hub. Behind that is Stream Analytics, taking the data out of IoT Hub. IoT Hub does not give you the data. You come and collect it. The interesting events, they go into the Event Hub for further processing, like queuing. And then there's a web job that pushes some information up to the user interface. That is usually the things like the thresholds being exceeded. And here is the Lambda architecture of storing everything that needs to be stored. Naturally, there's a lookup database. In this case, it's a document DB to see what is this device. A device, serial number 455. Who can tell me what it is? I don't know. It's probably in some database. So you need some lookup. And that might be populated from ERP system. And then there's naturally also some logic apps. There's a logic app there that you can do interfacing to some other backend systems. So that's quite an easy architecture. You spin it up, click, click, click. 12 minutes later, that's deployed and that's running. You can do it in your own subscription. Then you can start playing with it and seeing what it does and how it does it, and look at the queries that are running in Stream Analytics to see how they're doing it. As a Stream Analytics SQL-style queries, select star from where, with tumbling, hopping, type windowing functionality, group by, etc., etc. Then there's also the predictive maintenance one, and it's sort of it's a bit, my bane, which I keep on hearing about. Everybody wants predictive maintenance. Only one problem. For the data scientists to do some form of algorithms, to create algorithms, to test the algorithms, they need data. And they need data that's representative of reality. So if you are a farmer and you start producing data from some sensors in the middle of winter, the model that the data scientist builds for winter does not hold true for summer. I mean, it's logic. It's the same thing in a manufacturing plant, the October rush to produce everything for the December rush. It doesn't represent reality. So the biggest challenge with predictive maintenance type solutions is you need a lot of data. And once you're there, then you can start doing the prediction stuff. This is the predictive maintenance one. They're simulating a jet engine coming from some real jet engine data, gets simulated, and after a certain number of cycles, it starts predicting that there will be a failure. As you see, this engine number 2 will fail, and then later whilst it's running, the other engine will also fail. What does that architecture look like? Slightly different. Very different. I'm just trying to figure out why this architecture looks quite similar, but it isn't. As you noticed, here's Azure Machine Learning. It gets called by Stream Analytics directly. I can call machine learning, which is actually, once the data scientist publishes it, because it's a web service, I can call it from within Stream Analytics, Azure Data Factory, my C# code, my Java code, from anything that can do a web post. So as you see, Azure Machine Learning is involved here and does the prediction and puts up his hand and says, hey, there's going to be a failure. The probability that there's going to be a failure in 156 cycles is this percentage, therefore the engine warning goes red. As you see, the rest of the architecture is very similar. Only one problem. If you were to implement this in a real-world scenario, how do you pay for Azure Machine Learning? So many cents per 1,000 queries. If you're receiving maybe 1 million data points per hour, that quickly adds up to quite a bit of money. So yes, in this architecture, having Azure Machine Learning being hammered from Stream Analytics as each data row comes in, that's okay for this scenario. But for a real-world scenario, you won't. You won't want an opinion on every single data set. If a sensor keeps on saying, I'm okay, I'm okay, I'm okay, what is machine learning going to tell you? The thing is okay. You don't need to pay to be told that he's okay. So quite often you do the machine learning after the first or the second step of processing. And I've got a real-world architecture showing that. That's why this is a great architecture, but if you do it in real world, watch out. There are cost implications, and that's one of those things with IoT. Cost implications are one of the drivers. If I start having light bulbs that in retail I sell for 20 euros or $20, and the back-end service to process this connected light bulb costs me $10 a month after 2 months, I've got a problem, So IoT is very cost sensitive. You're talking about cents to microcents per device per month that people are expecting. For a large machine like a Sandvik laser cutting machine, there may be 100 euros a month is okay because the machine costs a few million, therefore the price is there. But if it's a very cheap consumer thing, you have to worry about the price, and that is part of the architecture that you also have to look at. So, those are 2 architectures we can spin up for you. Click, 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 answer 3 questions, deploy. But what have real customers done? The towering IoT problem. Let's guess, building management. It's what everybody seems to want to do. I want to do IoT on my building. Everybody wants to do that. It's sort of half the requests I'm getting are at the moment building IoT. And then it's always, can I do predictive maintenance? Can I do what ThyssenKrupp Elevators is doing? Why? If ThyssenKrupp is your elevator supplier, why don't you just get the data from ThyssenKrupp? They will predict themselves when the elevator will fail. You want to tell me that you can predict the failure of an elevator better than the manufacturer. You've got a problem. But the rest of the building, there's everything in there. There's humans, there's air conditioning, there's plants, there's temperatures, there's chairs, there's even coffee machines. And if you look at a connected building, it's a baby smart city. You start with the buildings, and then you start moving up the chain, and hopefully one day we'll all have nicely connected, intelligent smart cities. So there's only one problem. It's brownfields. In every building, there's a building management system, from Honeywell, Rockwell, Siemens, one of those famous ones. And these BMSs are quite proprietary and quite old-fashioned. They don't talk to the cloud natively. Now, there are usually 3 types of users in a building. The janitor, he's the admin. You could regard him as the system admin. He's the important guy. He can usually do everything. He's the dangerous guy if his phone gets lost and somebody in a bar starts playing with his building. That's a slight challenge. Naturally, there's a secretary who wants to run her area and the boss, and then there's the users who also want to play with the air conditioning and that. The reality out there is BACnet. The protocol used in buildings is the building automation protocol BACnet. There are some buildings moving into the OPC UA direction where they are using that industrial protocol OPC UA to do it. Most buildings don't need advanced analytics yet. Most of them are more than happy. Can I open and close the blinds from an app? Can I see what the power usage is? What is the, how many people are on the 2nd floor? How many on the 4th floor? And I don't need to do prediction yet in most cases either, because trying to predict how many people will be on the 2nd floor on the Monday morning on the 27th of November, you need a few years of data to actually predict that correctly. And there's one big driver for IoT is the eco-buildings. What can I do on the building to reduce my power and my carbon footprint? Naturally, the server sitting in the basement does not have that type of capacity, doesn't have machine learning on it. It definitely doesn't usually have Microsoft R Server or SQL Server 2016 on it. So the building management system needs to be able to run by itself. It doesn't have to rely on the cloud to run, but the cloud is a great second opinion to do optimization of the building. So that is generally the way it works. Local logic, local intelligence, augmented by the cloud. And as you start collecting data, then you start doing the cool analytic stuff, et cetera, et cetera. Now, for this customer, it was quite easy. They said, we want to connect the building. We build our own hardware that connects to the BACnet, so we control the hardware. We want to be able to have that, an app that the janitor can see what's going on in a building, and he wants to also be able to control the building. Okay, that's not actually hard, and if you look at this architecture, it's not far off, the other architectures we've seen. There's a building with electronics in it, talking one of the IoT protocols, which I'll touch on later, to IoT Hub. There's a stream analytics job there who pulls the data out of IoT Hub. Why do I know we can use stream analytics here? Well, it's easy. We are controlling the format of the data because it's coming off the hardware that the manufacturer is building themselves. If I was connecting to some other building, stream analytics might not be the right option because stream analytics has certain limitations, which data formats it supports, etc. We'll get to that also. So the interesting events, as in 4th floor is running at 80 degrees Fahrenheit or 30 degrees Celsius. Janitor, there's something you need to do. The aircon units are having a problem. There's something you need to do. Or the lights are still on at 2 a.m. in the morning. Who forgot to switch the lights off? Or did the control system somehow not do it right? So interesting events get put into an event hub. There's a standard worker role that pulls these things out, runs some business logic on it. Quite simple. There's about 1,000 lines of business logic code at this customer. he feeds that then further into an event hub to queue, because, nicely, disconnected architectures that if one breaks, the rest doesn't break immediately, and it's good for queuing. And then there's an API app that reaches into Event Hub and reaches and looks if there's any information to be sent to the janitor. If there is, sends it to the mobile device. The janitor is authenticated using multi-factor authentication, 2FA. He's the system admin. If he leaves the phone in the bar, hopefully nobody can play with his building. Now, the other Lambda architecture, they go and store a whole bunch of data. They don't know yet what they're going to do with it. So what they've got there is an Azure Data Factory, like SQL Server integration services, but in the cloud. There's a job there doing a whole bunch of interesting data manipulation, and then it feeds it into a SQL database. Now you're thinking, yeah, but this is IoT. Why are we still got a SQL Server there? They don't actually have that much data. You could put there a Hadoop cluster if you want, but why? It's again costs. At the moment, they don't need it. They won't need it in 5 years either. The SQL database will be more than okay to handle what they have. And maybe by then, we're going to use something like Data Lake. And that in that SQL database, there's also nice usage graph. So when a janitor clicks on the app, he sees exactly what's going on. And there's an app for the janitor, app for the secretary, and app for the user. One app with security trimming. And that's what they wanted. They said, we don't want the bells and whistles. We are more than happy just to do this, because we are the bleeding edge in our industry doing this. By the way, this company also builds greenhouses. And they're doing the exact same thing. So guess what? The farmer can look at the app, what's happening in his greenhouse, and control his greenhouse whilst watching football or soccer. And for the farmers, it's earth-shattering that they can do this. I don't have to go down to the greenhouse, and I know what's happening out there. So as you see, simple project, implemented in 6 weeks by the customer themselves with a bit of guidance from Microsoft, not rocket science. That's actually quite a nice little project. And that's how you have to think about IoT. Start small, and then you start iterating. So once they have more data, we might stick a data warehouse there, or we might stick some other technology there, some big data technology, and start doing some stuff. And then we start adding machine learning, et cetera, et cetera. So that's that typical architecture. Now, I was talking about IoT Hub. IoT Hub's been out roughly about a year now. Its younger brother, baby brother, or its older brother is Event Hubs, and its older brother is Azure Service Bus. They use roughly the same technologies, the same protocols, plus the newer, younger brothers are better versions. They've got more technology, they've got more features. Now, I mentioned earlier you could use Event Hub. And you're thinking, well, why aren't you using Event Hub? It's probably cheaper than IoT Hub. Well, there's one challenge. Event Hub is one direction only, device to cloud. And Event Hub has a nice little limitation, which is documented, but most people don't notice, is per Event Hub namespace, you can only connect 5,000, you can only have simultaneously 5,000 connections. Not per Event Hub, but per namespace, you can have multiple Event Hubs in one namespace. So if you've got 5,001 buildings or devices you connected to, guess what? Event Hub says bye-bye to the 5,001st device. 5,000 connections. Now you have to set up another one, adds complexity. So IoT Hub is there, built there to scale, but really scale. You can quite easily connect 10 million devices to an IoT Hub. You can have multiple devices in multiple data centers and multiple device IoT Hubs in each data center. And these connections, the IoT Hub guys are assuming the connections are open and held open. Imagine trying to hold open 1 billion IoT connections simultaneously. You need a bit of infrastructure. That's why we've got Azure. Imagine you tried that at home with a nice little big telco-style Cisco router holding 1 billion TCP/IP connections open. I'd like to see what happens there. So IoT Hub, there to scale. And it's there to do two-way communication, device to cloud and cloud to device. Naturally, each device gets its own token. With Event Hub, everyone gets the same token. Oops, security problem. If everybody has the same token, you've got a slight problem. And it does support a whole bunch of other protocols, and a whole bunch of more protocols are coming. And it really scales. Now, how does IoT Hub actually work? It is a thing in the cloud that listens for connections on AMQP, MQTT, AMQP over WebSockets, in other words 443, or HTTPS. So even if you've got a firewall in your environment, it will still get over that firewall. And once the connection is built up from the device to the cloud, and once the device has authenticated itself and the whole TLS setup has been done, then a connection is open, and then there's bidirectional communications. And then the device can send data, and the cloud can send to the device data. And quite importantly there, the communication is TLS-based. It's encrypted. You can run unencrypted, but it's highly, 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 highly not recommended. You don't want to run unencrypted over the internet. Once the connection is there, you've got those typical semantics, send a message, receive telemetry, etc. There's also things like device management. I want to tell all the devices that over there on that Azure Blob Store, there's a new firmware update. Come and fetch that firmware update. Tell me once you've downloaded it. Then I'll tell you if you're allowed to install it. And once you've installed it, please reboot. Once you've rebooted it, come back up. I know you're good. Then I can tell the next guy to do that, etc., etc. All that type of device management is also part of IoT Hub. By the way, device management is in public preview at the moment. And the SDKs are in multiple languages on GitHub. Java, .NET, C#, Python, JavaScript, PHP. We don't care really what the device is. Because the SDKs are there, they're maintained by Microsoft, and off we go. Take those SDKs, add your code, include them. There's also devices that are Azure IoT certified that already talk those protocols, that understand IoT Hub. So there's devices the size of my Surface battery pack who can connect to industrial controllers, one side, talk to IoT Hub, the other side, and all what you have to do is configure a connection string, and it starts talking. So there's a whole bunch of cool device manufacturers out there, from guys like Dell to HPE to some small little company in Turkey or in China who has gone through the certification process to make it easier. And quite a lot of them do industrial protocols, some do Bluetooth, Zigbee, etc. Now, just quickly on this. There are many endpoints in the IoT Hub. From a device to the cloud, the device can send a message. It can also receive a message. From the back end, the Stream Analytics or your code pulls that message out of the receive endpoint. And what's important with IoT Hub, whilst this data is sitting in IoT Hub, it's persisted on storage. We do not drop the stuff on the floor when it arrives. That is the worst case scenario. That is, nobody would trust us if we'd lose your data. As the message arrives in IoT Hub goes and persists it. Once it's persisted to storage, IoT Hub acknowledges that message. In the case of HTTP, it's an HTTP 200. If it's AMQP or MQTT, it gets the acknowledgement. There's about a millisecond of latency on that. So if we say we've acknowledged that message device, it means we have it and it's securely stored. Now, there's a competitor who doesn't do that, and if you don't come and fetch the data, it falls on the floor, and you've lost your data. Now, IoT Hub can also be configured between 1 and 7 days of storage. So I can have IoT Hub be my temporary storage of all my inbound messages. We'll store it between 1 and 7 days. You configure it. After 7 days, we will delete it, because that's the maximum. We're not your long-term storage. So even if your back-end systems are offline for 2 hours, IoT Hub can carry on sending and receiving messages. It's fine. Just come and fetch them then, please. And then you can also, like I said, you can send messages from the IoT hub, and that's exactly done the same way. If the device is offline, the message gets parked until the device is online, and then when the device is online, it gets sent. There's also semantics like time to live. So I can tell a IoT hub this message to that device, deliver it in 10 seconds or kill it. Why? Because that's a message to tell the garage door to open. If the garage door doesn't have internet at that time and gets internet 2 hours later when I've gone to work, guess what? The garage door opens. Great. That's not exactly optimal, you know. So the IoT hub has those type of semantics, and IoT hub knows if the device has received the message, acknowledged it, etc., because that's part of the whole semantics. And that's through the message feedback and event monitoring endpoint. And then there's also a provisioning API to provision the IoT hub, etc. So IoT hub is a lot of stuff, and we're adding more and more and more and more features. We'll be adding more protocols in Frontier. As a protocol gets ratified in the standard, we add it into IoT hub, we add it into the SDKs, and off you go. Because we want to support the protocols out there. We're going to add a lot more functionality in IoT hub. So it's not just this dumb pipe to receive data and send data. It's a very full-featured cloud gateway for bidirectional communication. So, like I mentioned, we support currently 4 protocols. If you've got a different protocol, you can, there's also an SDK out there, put a cloud protocol gateway. It's called the Cloud Protocol Gateway. It's a code sample on GitHub in front of it, and then have that code converted into something we understand. Why? Ideally, after IoT hub, you'd like the same message format through the whole system, because otherwise you have to handle all the different message formats. And I mean, there's even a Storm spout to talk directly to IoT hub. I mean, it's not rocket science. Off you go. There's also a Field Gateway SDK. And that Field Gateway SDK, it's that gateway. And that gateway SDK understands IoT hub, and it understands devices, and it can be an intelligent gateway between IoT hub and the device. Why? There's something called fog computing or edge computing. That's what you need out there in IoT land. If the internet line is down, you hopefully can still carry on running something and you can still carry on processing. That's what edge processing is great for. It's also great for saying, this device has been telling me every second, I'm okay, I'm okay, I'm okay. So the Field Gateway might turn around to the cloud and say, hey, this guy's been telling me the last 30 seconds he's okay. Turn 30 messages into one message. Or it might do some form of encryption or do some protocol translation. So the Field Gateway's job is also to do that fun work. So that's also just sitting on GitHub there. Go and use it. What the gateway has in addition is a master key. So if the gateway wants to send on behalf of the devices, it needs to first build up a connection, authenticate. Once that connection stands, then it's allowed to send on behalf of the devices. Because otherwise, some guy just goes and creates a phony gateway and starts relaying messages and sniffing them. It's not exactly what we want. So even the gateway has to be trusted to know that somebody hasn't gone and created some funny data. Perfect example with a gateway is in those elevators from ThyssenKrupp, for the elevators who aren't the newest generation, they've got in the shaft a box, and that is their gateway that talks to the elevator. Now, if a competitor were to go in there, go onto the device, take the credentials of the device, take the software, and start spoofing data, what will happen? They haven't hacked the cloud, and they haven't hacked the device. They're just creating bad data. So what might the back-end system do? Oh, those 25 elevators have got a problem. Send out the technician. What do you have? Denial of technician. Because the technicians are running around fixing elevators that don't need to be fixed. So that's always one of those security challenges also. So the gateway, also very important. Now, next customer sample. Now this customer built this 18 months ago. And I'm going to talk you through this existing implementation and how we could change it to modernize it. because that's what's going to happen. So it's connect my medical device, typical consumer medical device, Bluetooth. The physician wants to access the data, and the architecture has to meet regulatory compliance, HIPAA. This technology, like I said, was 18 months ago, and the development costs are sunk already. They're not going to just throw everything away that they've done. So they need to migrate it in a way, and V2 of the thing will be there to eliminate the compromises. And this is exactly what the architecture is like. And you realize that, hey, there's no IoT hub in there. Of course not. There was no IoT hub at that stage. And IoT hub only got its HIPAA certification, I think, about 3 months ago. So we couldn't have used it until about 3 months ago in any case, because this is medical data. Another one of those, Event Hub was HIPAA compliant, IoT Hub not yet, because it was the younger one, wasn't in the audit cycle yet. Therefore, they had to make a compromise and use what was available and what was compliant. So what they have is an iOS-based device. It's talking Bluetooth to a band and to a blood pressure cutoff device. It sends via AMQP to Event Hubs the messages, this phone. By the way, Event Hub only supports AMQP. It doesn't support MQTT and the other future cool stuff. From there, there's a web job that pulls it out of IoT Hub, sticks it in a service bus queue, throws it at a Logic app, and the Logic app does integration into the Microsoft Health Vault and Microsoft Dynamics CRM. And if the physician wants to look at the data, he looks at it through the data store in Health Vault via the API app through a website, and the physician can look at it. And the physician can then send the user a message, hey, take your medicines, please, because your data doesn't look too good. And how does it do that? The API app sends via a web job to the notification services, that service that talks to the Android, Google, and Microsoft push notification services and sends it a pop-up or a toast or a notification to the phone. And then there's naturally still the mobile app technology on Azure that the phone connects to come and look where the user can go and look at the history of the data. Now, that architecture works. There's a few optimizations that could be done today, but it works, and there's nothing wrong with it. That's why I'm showing it. And it is old, it isn't legacy, and all the technology there is still platform as a service technology, and not one of those things have been deprecated, and they probably won't be deprecated. Everyone uses Service Bus, everyone's using web jobs, everyone's using Event Hubs. Event Hubs is absolutely critical, so there's nothing wrong with this architecture. There's just one thing out there. The gateway's changing from the phone that the devices can talk to themselves to the cloud. Even a health, blood pressure monitor, I see some out there that have got a 3G SIM card in them and they're talking themselves to the cloud. That's where Gartner comes up with 30 billion devices by 2020. It's not 30 billion cell phones. It's going to be all these devices who want to talk themselves, if they are capable. So always remember that. Now, what would we do to this architecture to modernize it? Number one, we could replace Event Hubs with IoT Hub. You've got them bidirectional communication. I could also replace Service Bus queues with Event Hub. It's cheaper and it scales better. Service Bus has a pub type subscription. Event Hub is like IoT Hub. Feed data in and suck it out on the other side. Logic App is good. The web job, you might replace with an Azure function. So instead of having something run continuously, you have an Azure function, which is currently in preview, that when it receives data from Event Hub, it acts on it and does something with it. So it's not this polling type scenario. It's literally a acting on the data as it's coming in, using the latest technology, but we can't use it yet because it's not HIPAA certified. So back to web jobs. Would I replace notification hubs with IoT hubs bidirectional communication? No. Why? Battery power. if the phone had to continuously hold the connection open to see if it's going to receive a message, it's going to use a lot more power than using the push notification of the phone. The phone push notification is highly efficient. Microsoft, Apple, and Google made sure that those are very efficient ways of doing it. For those who don't know, it actually uses one of the back channels as an SMS to tell the phone that over there's a message for it to go and fetch that push notification. It's just that's how those things work. So I wouldn't replace IoT Hub, the notification hub, with IoT Hub. Why? Because battery power. It's again, this is a consumer device. Don't eat all the battery power. And the mobile app you will probably still need, purely because the user still wants to look at data, needs to do authentication, needs to do registration, etc. So of this whole thing, replace 2 components. It will scale better and probably cost a little bit less money. Don't need to do much. And I mean, if you want to, you can also replace these devices with nice Windows phones or Windows mobiles. No, seriously, it works. Give the customers what they want. I don't care what device you've got. As long as you're using Azure IoT services, I'd be very, very happy. And the back end, you don't need to change either. Maybe you could give the physician an app instead of a website. But that's, V2. Now, this is where IoT goes really real world. Because up to now, it's been easy. We have things connected, a building connected, which has always got internet, hopefully through some fiber. There's a device who's got usually a gateway as a phone. Now let's talk about the Internet of Trash. That's the other shortening for IoT. Connect this. Where's the battery pack and where's the plug for the power? Now, if you look at the requirements, this was the customer requirements. Want to know how full it is? Makes sense, because they want to optimize the routes to determine when they need to come and empty this thing. They are located everywhere. Inside a building, in the basement, outside, out in a field, the ones who got stolen on the back of a truck or in the river. And the customer said, I want 5 years battery life. And they said, by the way, we'd like 3 or 4G communication. The first thing I said, guess what? You can have one of those 3. Not 2, 1. Because anybody who knows, how long does a battery on a cell phone last in a 2, 3G connection? They want 5 years out of something maybe a bit bigger. No, won't work. 2G, 3G, 4G just doesn't work for that. Maybe in future 5G will have something. And at the moment they're connecting 1 data point per day. And I said, hang on, you want to know when this thing is full? Yes, they said, they need to know that it's full. I said, but why? Wouldn't it make more sense if you get a data point every hour? Because then you know when it gets filled, when it gets full, so you can optimize and say, we know that thing is full at 9:10 every morning, because that's when the janitor throws everything into the trash. Then you can optimize your route based on when it's full, that you don't actually have a full one of these, or you go to the thing at 8:10. Janitor has thrown nothing in it, it's empty, you go and then the janitor fills it up and now it's full and it's full for the next day. Oh, that's a good idea. The business didn't think about that. They were just saying, I want to know when it's full or empty. It's not, what can I still do with it? Then I said, well, if we do that, then we can start optimizing the route. How can we optimize the route? Based on how full these things are. And based on predictions, we can then say, we know that at 9:10, based on history and on predictive algorithms, that container at that building will be filled at 9:10 every day. So at 9:15, you can go past and fill it up, empty it. And they also want geolocation. And then they said, hey, but if we're adding sensors, can't we determine what's in there? If it's cardboard, it doesn't stink, so that's okay, can wait a few more hours. If it's food waste, go and pick it up as soon as possible, because they might go and pick it up to take it to the methane conversion plant to turn that methane into gas so that they can use it to heat homes. And the faster you get into the methane plant, the better it is, because then the fresher the rubbish is. Oh, cool. So, from a please connect my trash can, it turned into a cool, look at all these other business models we've got. And that's sometimes your job also, to give your business or your customer some additional ideas, because they just look at it from one point. You can say, but we could do so much more. Maybe you don't do all that more in the first step, but you might do it in the second step. So another question is, how do I connect this? I've got a serious problem. A cell phone doesn't work for 5 years. And they said, we want all of those. I said, okay, let's play with some technology. What if we put solar panels onto these trash bins? Little solar panels, or based on movement, do energy harvesting. Wow, you can do that, yes. There's companies out there who do that. There's some very innovative startups who are doing that, and some large companies. I said, but why are you saying 3 or 4G? They said, yeah, but my telco said we should use 3 or 4G. I said, hang on, your telco wants to sell you a SIM card. How much is he going to sell you a SIM card for? And he said, the SIM card will cost $8 a month. I said, hang on, the back-end services of this thing, if we do it right, will probably cost you 10 US cents a month if we really do it badly, and if we do it optimally, about 5. I said, there's no relation here. So you're going to have a cost per month of $5.05. And we're the cheap part. And we're bringing the value. I said, there's other connectivity technologies. For those who can't see, these are very small little devices. They are similar like the Texas Instruments smart tags with 12 sensors on it. This one here, the size of my fingernail, it's got a watch battery and it lasts 2 years. Talks Bluetooth, we'll talk one of these days, 6LoWPAN and Zigbee also. And this one is the same version except it's got a solar panel. This one, the battery-powered one, has roughly a retail price of $1 per device. And this one's got $2, and probably in about a year or so, the price will probably close to halve. So I said, imagine we put a $5 sensor on there, not the $140 sensor you were talking about a $5 sensor, but we use a different communication technology, and no, Bluetooth is not the option, because otherwise the trash guy has to go and pair his phone with all the Bluetooth trash bins out there. Because immediately a guy said Bluetooth. I said, okay, no. There's other technologies out there. I'm glad it is. So, what's the architecture? Quite easy. There's networks called Sigfox and LoRa. They are very, very low-powered, relatively long-range radio networks running in the open frequencies of 868 and 930 megahertz. Those free ranges, which anyone can do anything on. Sigfox can send 144 times a day, 12 bytes. Literally IoT. It's not a streaming service. 144 times a day, you can send 12 bytes. With LoRa, you can send a bit more. You can send 50 kilobytes quite often. These devices will use the same amount of battery like these type of devices are producing. Because those LoRa and Sigfox devices are built for very low power. Why? They're not continuously transmitting. They get a time slice and then they transmit every now and then. So perfect for this scenario. We're not doing real-time telemetry of a car. We're doing semi-real-time telemetry of a trash can. These networks are also very cheap to set up, and you'll see that they're going to be spreading all over the world. In Europe, they're quite well deployed already. The LoRa and Sigfox networks, both of them use a base station the size of a laptop that costs about $1,200 a month. That the hardware costs $1,200. You connect it to some internet, feed it to a network gateway service that is LoRa or Sigfox that understands it, because all the brains is in the cloud, and then you've got devices who are connected. Very cool technology, and it's bidirectional, which is important, because even if you've got a water sensor in the garden that reports once a day that the ground is dry, you might want the blinky light that you as a human know that's the water sensor that's complaining. So you've got bidirectional. Just so you know who they are, LoRa Alliance, that's from a French company. Some guys in France invented this technology and has been bought by Semtech, a US company with strong presence in Europe. So that's LoRa. And the other guys are Sigfox. It's another French company. Somehow the French guys seem to be figuring out how to do this low power technology very well. And they provide a end-to-end service. So you could nearly say they're a competitor to the telcos, because they don't license their technology. They are, as a company, set up these networks. And by the way, a base station's got a range of between 8 and 20 miles. Yeah. That's why something like Atlanta, look, Atlanta's big. I could probably cover it with 10 base stations. So have anyone got $12,000 and a bit of internet? You know, that's the beauty of the stuff. In Europe, in a city like Zurich, they're covered with 4 base stations. And guess what? LoRa supports triangulation and supports geolocation. How? It doesn't use ping times. It uses signal strength to determine its location. It measures the signal strength of the various base stations, sends it to the base station and says, by the way, this is my signal strength that I'm seeing, and then the cloud does the hard GPS crunching. Why? Because that uses power and battery. The devices are dumb. They've got sensors, they transmit and they receive. The hard work gets done in the cloud. So things like Sigfox, excellent technology also. You'll see a lot more of that type of stuff carrying on, and you will have a lot more of that technology over the years developing. The 5G guys aren't asleep. There's technology coming from them also. So don't worry. That's the least of my worry. They will also carry on. Now, interesting. Doesn't want to carry on presenting from my slide deck. So let me close it. It's always interesting. Now, how would I do that architecture in a reliable manner? It's quite easy. The Sigfox and LoRa networks are gateways. They talk directly to IoT Hub. We as IoT Hub don't talk to those millions and billions of devices. The Sigfox and LoRa network gateway service. So there is actually a cloud-to-cloud connection. It's like that cloud-to-cloud connection with Ericsson or with Jasper for their device management stuff. It's a cloud-to-cloud. They just talk to our IoT Hub. You go onto their network gateway servers, configure the IoT Hub, and then they start throwing data at us. So IoT Hub is there. Behind that, there's some stream analytics for this customer. And stream analytics is capable of doing lookup data, reference data. So there's a blob there with reference data that every device that sends its data, it sends a serial number. Then they enrich that data and say that is trash bin 45 at customer 204 at that location, or should be at that location. And then that data flows further through the system already enriched. You don't have to go and do then database lookups. Stream analytics can do that as a left inner or outer join as part of the semantics. Great technology, but stream analytics only supports JSON, Avro, which is the form of, which is the Apache version of Google's protocol, and CSV. Oh, it doesn't support XML. So if you have XML, you can't use stream analytics. Oops, then you have to write code. Stream analytics will, I can't speak for them, but hopefully one day they'll add more data formats. So there's also, then it's written to the blob, Lambda architecture, keep the stuff, we never know what we're going to do with it. The data gets written into a data warehouse, because why do we do it in a data warehouse? The existing tools are Excel and a few ODBC connecting apps, so they need to get the data out of an existing relational database that they understand. There isn't that much data either, not a problem. There's a web job that goes punching through this data and looks for interesting events and saying, hey, that trash can has moved. Why? It used to be there, and now it's on the other side of Atlanta. Is something wrong here? Has it been stolen, or have we moved it and somebody didn't update the system? Because now if your route planning is based on the location of a trash can, it gets funny when the trash guy gets there and says, where's the bin? I'm told it's here, but it's not here. You know, it's peekaboo bin. So they found that was their biggest problem. Nobody's looking after their reference data. They don't know where their bins are. So their first step was go around, instrument the bins, figure out where they are, and then they figured out 80% of them are not in a location where they thought they were. How did they know which bins to come and collect from? The trash guys knew their route and knew where the bins were. It's that human knowledge. That human knowledge wasn't updated in some IT system, therefore there was a disconnect between field and real world. And there's also a logic app which does the integration to the ERP system to go and fetch that reference lookup and customer information, and are we supposed to collect that bin, etc., etc. And there's some nice UIs. Quite easy. Architecture looks very similar. Now, when somebody says add machine learning, I just punch machine learning probably into the web job, add machine learning in, and I've just added more value to their system by adding in machine learning. I might then long-term maybe put it into the Azure Data Lake and use the Data Lake as the storage and the processing for this. So just add more components. And one day they'll just replace the web job with the Azure function because the Azure function might be more efficient. So you just throw things in and out. The main thing is this thing better stay where it is because that's what the devices are connecting to. But I'll touch on that also a bit later. So here it gets really interesting. Industrial IoT, IIoT. That's what everyone's calling it these days. Industrial IoT. Very interesting, because this is hard. And I'm serious, it's hard. I did this many years ago when I was working for Siemens. Then it was hard, and it's even harder today. Why? Things called PLCs. This was at Hanover Fair, the world's largest industrial fair in Germany, in Hanover. And that was where we were having PLCs hanging on a board connecting to IoT Hub and controlling the PLC out the cloud. And everyone said, what is Microsoft doing here? You guys aren't industrial guys. We said, yeah, but we are. There's something called OPC. It's the industrial protocol to the modern industrial protocol for machines to talk with each other. OPC is 25 years old. What does the O stand for? OLE process control. Hang on, OLE, isn't that stuff we used to have in Word and Windows 3.1? Yes. The industry built on our OLE technology communication protocols to make these PLCs, these industrial controllers, talk to each other. So we can have claim to fame. We've always been involved in industrial IoT or in industry because that's our technology. We just let them do it. And we're a member of the OPC Foundation. So there are all these different PLCs. This is about this size. This is a Siemens one. Very interesting. There's CPUs in there, I/O ports, plus a whole bunch of logic, memory cards. It's a little PC. When I worked for Siemens, something like that would have cost about $15,000. These days, these things cost $1,000. They're cheaper than your laptops. Industrial PCs are cheap and are expected to last 20, 25 years. This is from the German competitor, Beckhoff. Guess what? This thing runs Windows 10 IoT Core. Why? It's got a Celeron processor or an Intel Pentium 3, 5, or 7 in it, an i3, 5, or 7. These are standard technologies we know. And you know what this here is? This is a hard drive. It's the same hard drives we use in our servers, solid state hard drive. And here's the ports to connect to all the funny protocols out there. And as you see, there's an IoT label on there. These things can talk to Microsoft Azure, IoT Hub, Amazon, Google, and Salesforce, out the box. So you can connect these things. That's why these things are going to be the gateways of the future. I'm not going to stick something behind them to talk to them. They're going to just call the internet themselves because they're capable. And one thing you must always remember with industrial PLCs, you never patch those things. You never touch a running system. They will run the same firmware version for the next 15, 20 years. unless the manufacturer says, there's a bug, please patch it. So it's a different world. It's that OT versus IT. But this stuff is cool. And I can tell you now, 80% of IoT projects long-term will be industrial IoT projects, because that's where the biggest value add is. Turning on and off a light bulb through a phone is not exactly cool IoT. While I'm on that topic, why should I switch on my light bulb with my phone? I first have to unblock it, start the app, connect to the wireless. Why doesn't the light bulb realize Mike is walking out the room, tells the light bulb in the next room, Mike's coming, switch on. But the other light bulb is clever enough to know, hey, Mike's girlfriend is sleeping, so don't go up to 100%, go up to 10%. Give Mike enough light that he doesn't fall over the cat, the dog, and the shoes on the floor. That is IoT. IoT is not connecting a phone to light bulbs. Sorry, just had to add that in because, it drives me up the wall, that stuff. Everyone talks about IoT, and this is hard. That's why the guys in Silicon Valley don't really like this stuff, because this is talking to big players who exist out there. Why? There are so many old protocols out there. Up top is some of the protocol soups. OPC has got 3 flavors. There's Profinet, Profibus, SCADA, CAN. CAN is what you have in your cars. That little, when you go and tap your car, it taps into the CAN protocol. BACnet, Modbus. There's everything. I could have a slide just on that. Then there's a problem. There are so many PLC manufacturers out there, each one using their own OS, having their own implementation. There's no standard that everyone runs a Linux or a Windows. They're running some industrial firmware written hardware, non-agnostic code that somebody wrote probably 10 years ago that they're still managing. There's, at last count, over 800 PLC manufacturers. And guess what? You walk into a factory, like a large chocolate manufacturing factory, you're going to find at least 12 different PLC suppliers. Then each model's probably 20, 30 different models. So immediately you've got a permutation of 600 devices. Cool. That's easy to integrate to, isn't it? Because you have to understand each one. That's why I say industrial IoT is hard. And then the problem is then you have machines. And some manufacturers put a Rockwell PLC on the machine 1 year, and the next year Siemens, because Siemens gave them a better deal. So you might have 3 machines all using the exact same machines using different PLCs. But they behave the same to the operator, but to you, it's different. I mean, Rockwell is bigger in the US, whilst Siemens and Schneider is bigger in Europe. And then you go to guys like Fuji, Panasonic, Toshiba, Mitsubishi, they've got Asia. So if you think you can build one industrial IoT platform that talks to everything, good luck, because you're going to have to support lots. And then there's the integration, because that's the most important part. Integration is ERP, logistics, the manufacturing execution systems, the system that determines what happens on the production lines. It tells the PLCs what they need to do, and the PLCs then tell the machines what to do. Robot, move your arm 10 times a second, please. That is started off by the manufacturing execution system, and then here comes the best part. In the MES world, the engineering companies and the manufacturers all thought build your own is best. So half the manufacturing or the companies out there have built their own proprietary MES system. That probably was built 20 years ago, and the guy who wrote it has retired, and some young guys trying to look after it and still trying to understand it. And the other 50% are using 2 or 3 off-the-shelf MES systems. So even trying to integrate to know what's happening on the production line, the context of what's happening on the PLC, to talk to that system that actually knows what's going on, that's another huge integration project. And they don't have a beautiful web API or a REST API. They probably say, I'll give you the file on an FTP server once a day. That's the type of world industrial IoT is on. So, real world, how do you connect those things? I said earlier we have IoT. IoT Hub has got the SDKs. We have written an SDK that supports OPC UA. It's on the OPC UA it's on the OPC Foundation GitHub. You can use it, open source, it can talk OPC UA. But you saw all those other protocols. Quite often you use something like Kepware, which is one of those companies who's got hundreds of drivers for all these funny PLCs and all these funny combinations. They then talk to the PLC on a server, a physical real server that we know, those type of things, somewhere in the factory. And then that we can go and tap on through OPC UA. So we don't have to tell Kepware send the stuff to the cloud. We can actually tap into Kepware. So this part, the hard part, either we've got the solution or we've got a partner who does the solution. We've also got partners who do hardware gateways, who talk those industrial protocols. And then all talk to IoT Hub. That's easy. Oh, now this architecture looks very different. Why? Because those data formats coming off those PLCs isn't nicely formatted JSON, CSV, or Avro. That is anything. It could be binary, it could be JSON, it could be a bastardized version of JSON, it could be a bad implementation of XML, it might be something using XSLT to do some weird stuff. It can be anything. It could even be an FTP server. So what do we do there? Use the newest technology, Service Fabric. Service Fabric, the actor framework, letting it run there. It's, why build now something based on a worker role when you've got something like Service Fabric? Service Fabric is the better way. At the same time, you can create a digital version of your PLC in the cloud as a reliable actor in Service Fabric. So when you're interacting with this or trying to understand the interactions between the PLCs and what they're doing and the data flowing, you ask those virtual PLCs in the cloud what they're doing, and they just get the data off the real PLCs. So Service Fabric, great to do this. Get the architecture right, beautiful. Service Fabric does the integration also through Logic App into the MES system. And I can tell you, you're going to have BizTalk there or some other integration technology, might be Microsoft, might be whatever. There's just going to be lots of that. Then Service Fabric writes, in this case, at this customer to a SQL database. Why? The tools that they've got are Excel. They need to query a relational database. They can't exactly talk to a Hadoop cluster. They could, but they don't want to yet. And then they are using Azure Data Lake Store and Analytics to do some nice crunching of the data. They're using some of the USQL. They also got a Hadoop cluster running against some of that data. And then there's Azure Machine Learning doing some predictions. The data is all encrypted using Azure Key Vault. And then the standard API apps and apps out the back. This architecture I've got at about 12 different manufacturing companies. And it's sort of, the only thing that changes is the business logic really in the Service Fabric. And that is very, 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 very customer specific. And that's the hard part, making sense of their data. Because PLC register 4 on the Siemens S7-300 on one chocolate making machine does not have the same temperature setting or the temperature sensor as the Rockwell one on another machine at an American company. It's like every time it's a new project. But this is one way of doing it. And there is another customer, Weir. They're a case study on the Microsoft website. Very similar architecture to this. They just do huge pumps, as in these big water pumps that are down the mine shaft. So yeah, it's not exactly rocket scientists, but this is the simplest architecture. You see there's no web jobs and all that stuff. Service Fabric does all that work. Now you've probably been thinking, hey, hang on. What about HA, disaster recovery? There's a whole load more to IoT than just collecting and sending data. Yes. Slide is that you can look at if you want to, the Service Fabric stuff. There's also been some sessions. Let me now touch on global deployment. How would I architect for this? Because I've been talking about one IoT hub in one data center with one stream analytics or multiple stream analytics job, with one database, with one data lake, with one everything. What if somebody like Nestle comes to you and says, hey, I've got factories in 22 countries. I've got some regulatory requirements that the data in the US stays in the US, the data in Germany stays in Germany, the data in Europe, the data in China. Oh, and I've got a factory in Brazil, and I need to connect that also, and there's a factory in Australia. Are you going to stick one IoT hub in Europe there and hope that it works? No, it won't. You'll probably do a highly distributed architecture, and that's the beauty of Azure. I just go into all 30 regions now and say, give me an IoT hub. That's cool. I tell the devices to talk to one of them. Oh, how do I do that? Oh, and how do I get the data off those things? Now, imagine this. A device wakes up. First time it's ever woken up. ET wants to phone home. Where's home? You don't know. It doesn't know. Because if you've burned some firmware setting into this device, and it's now been sitting for 3 years on the shelf, when it wakes up in 3 years, when it gets installed, have you still got that IoT hub with the same name and the same key sitting there? You need some form of service to actually do the provisioning and say, hey, wake up, time to get up, I need to do something. So at the moment, you have to build this yourself, DIY. The best way of doing it, having multiple IoT hubs around the world, have a web app that is an HTTP REST endpoint with one static name, which you can say, I will carry on supporting for the next 20 years. Use Traffic Manager to send the traffic from India to the Indian data center, and then the web app in India says, oh yeah, this guy's coming at me from somewhere near India because Traffic Manager sent him over to me. Therefore, he can talk to the Indian IoT hub, and the Chinese one to the Chinese one, and the American one to the American one, and the German one to the German one. So that you could do with a few hundred lines of code. You have to build it yourself at the moment. So what we call front door provisioning bootstrapping service, this is generally how you would do it at the moment. It would be nice if the product group were to build something like this for us. But since I'm not in product group, I can't talk for them. But it would be nice if they would do that, something for us. And if you scream loud enough, they might do it. So imagine you've got an IoT device. It wakes up. It talks to myiotdevice.mycompany.com. It doesn't care if it's on Amazon, Google, Microsoft. Tell me where I must talk to. That service then returns an IoT hub endpoint and the credentials and says, go and talk over there. And then the device can talk to it. Now, in the case of a Rolls-Royce jet engine, this might be done on every time it lands. Because when it's landed in Australia, don't talk to the European data center, give the data to Australia and backhaul it across our data center networks into Europe. Makes more sense. So you might use that for that provisioning service for every time the device is moved. A container moves, an airplane moves. A car might not move that far. I mean, might not need it, but you still need the rest of this to provision a car. And most IoT projects have got something of this type of thing. And this would also be the way you could do HADR. Yes, IoT Hub is running on many servers in a data center, many, as in hundreds. So if we have a single server failure, who cares? There's another one to take its role. But say we have a larger problem. You could then tell your provisioning service, I know that's not the closest data center for India, but please tell those things to talk to Singapore. Because you just configure your service to say, Traffic Manager can't talk to India. Traffic Manager won't send it to India, therefore it will send it to Singapore. Cool, automatically your devices can carry on, but what about your business logic? If you've got business logic depending on data that's already in the old data center, that's another architecture decision you need to make. I can't solve that for you either. But it's downstream architecture things. And yes, you might want to use it for migrating, where you might actually say, I'm giving my customers the IoT devices. You can use my IoT service for free if you send 10 messages per day. If you want the paid service, we'll move you into another IoT hub where we guarantee you SLAs and that. So you can even use it for your business process to start moving devices around to the IoT hubs that you wanted to talk to. And how would you do that? Have multiple IoT hubs and probably a service fabric behind it who pulls the data from all those IoT hubs and does the work on those. Or you might have one of these in Asia Pacific, one in Europe, one in the US, and you do regional type deployments. It's up to you, but this is really what you need to think about in a global type deployment. And the service fabric, its job is to take the data out. Know that if a device is connected to IoT hub in Singapore, don't send the command to the Indian IoT hub because the device will never get a message. Send it to the Singapore one. Why? Because you can ask the IoT hub, is this device currently connected? When last was it connected? Oh, it was last connected to the Singapore data center, therefore we know that's the one. Then naturally do things like device management and all that interesting stuff. Do the synchronization of the credentials between the IoT hubs, because if you've got one device that can talk to many IoT hubs, you have to provision that device in all the IoT hubs that it could potentially talk to. So you need to somehow synchronize that. So if you change the key in one, change it in all of them, please. Otherwise, the device can't phone home anymore. And you might do some business rules. So that's typically the type of architecture between device and IoT to do global type distribution. Here's a whole bunch of links. Reference architecture, there's a nice security architecture where they talk about all this. The IoT suite, there's the link. The GitHub IoT code sitting out there. The OPC UA stuff is out there. These are some of the other sessions that I think if you get the chance to see them, go and watch them. Otherwise, go and watch them online. I am now finished. Are there any questions?